So your test is 15 questions. No, your test is 19 questions. One is a graph, so the graph will count for extra points because it's got multiple parts. Okay. It is a blend of multiple choice and short answer as per the usual, and it is no calculator. Okay, the whole time. So it starts with 2-6 and it went to 2-12. In 2-6, which was also on your quiz, you had to determine what model is appropriate. We're looking for a pattern or not pattern, right? Pattern would be not appropriate, no pattern appropriate. Then also in 2-6, when we were comparing our residuals, right? You're looking at the dots. And on a residual graph, if the dot is above the model is an underestimate, and by the vertical distance. And if the dot is below the horizontal line, then that model was an overestimate. Okay, so hopefully we know how to read those and to be able to decipher from there. For 2-6 and 2-7, which kind of put together, 2-7 and 2-8, which was the composite functions and the inverse functions, just like your quiz, you got to be prepared to be able to find a composite function, its domain, or adding, subtracting, multiplying, dividing, any of those kinds of functions, and also those domains. As a refresher, on our composite function, we only carry down the one on the right. So if this said f of g of x's domain carries down, then we check the new one. If it said reverse, g of f of x's domain carries down, then we check the new one. All the other ones, both initial ones carry down, and then we check the new one. We good on that? Okay.
Wait, which one do they both carry down?
All of these.
Okay.
Yeah. Because we can do f plus g two ways. If I did f plus g of 2, I could take 2 and plug it into f, take 2, plug it into g, and then add them together. Or I could take the initial functions, add them together, and then plug 2 in after. So I got to make sure I check the restraint on the original f, the original g, and also the combined one. Whereas on these, the only thing we can do is plug it into the one on the right, then we take that answer, plug it into the left. We never plug directly into the left. Does that make sense? Okay. All right, so then f -1 inverse, we need to be able to find from an equation, from points, from data like in a chart, and also your domain and range, okay? We know domain and range on inverse functions would switch, right? If I gave you the original, it would switch for the inverse function. All right, then we add log functions, and on the quiz there are basic log functions. You're simplifying, same thing here, there's gonna be some basic ones. And then there's the ones that are like I forget what your word problem was, but there was a word problem, you had to plug it in, you could see something like that again. All would be able to be done without a calculator though, so keep that in mind. They're all ones that would be able to be simplified. Also we asked the question differently on your quiz. So on the quiz I would have said like approximate log base 3 of 2. Now it's gonna say write it as a ratio of common logs and a ratio of natural logs. So this was in last night's AP classroom. Remember the rule is that I can rewrite this log as a ratio of a log of any base of 2 over a log of any base of 3. The base goes to the bottom. So if I want to do a common log is literally log. This would be log of 2 over log of 3. That's the equivalent of log base 3 of 2. And if I want to write natural log is ln. This would be ln 2 over ln 3. All 3 of these things would give you the same answer. Yeah. The base goes to the base. So base goes to the bottom no matter what these values are. Base on your log goes to the bottom of the fraction. Patricio.
Right, so when we find the inverse, how do I find the inverse of the domain and range?
If it gave you original domain and range or a way to find domain and range, like let's say get a graph or something, you would switch.
So range is domain.
Correct.
Okay, thank you.
Okay, then came all the stuff after the quiz. So 210 was inverses of logs. So you could see something like this where it says, here's a function, find the inverse from an equation, from points, and from a graph. So let's practice from the equation. If I gave you f of x equals 2 log base 3 of x, then to find the inverse, what do we do first? We're going to make it y. Then we're going to switch the x and the y. Then what? Divide by 2. I can't get to the log until there's nothing on the outside. So I would divide both sides by 2. I'd get x over 2 equals log base 3 of x. And then the 3 picks up the exponent. So 3, oops-a-daisy. This should be y. Nope. Yeah, I switched but didn't switch that one. 3 to the x over 2 would equal y. And then the very last thing I'm going to do is, it's no longer y, it's f negative 1 of x. So this is the inverse of the initial. So change f of x to y, switch the x and y, solve for the new y, and then make sure you change that y to f negative 1 of x.
Does this say x over 2?
In the exponent, yep.
And if the log had like if it was log 3 of 2, you move the 3 over and like the 2 stays in.
Correct. All right, then go to exponential. So same steps, but now we're doing it on exponential function. Make it y equals 2 to the x minus 1. Switch your x and your y. X equals 2 to the y minus 1. Now I want to get to the y. So the first thing I'm going to do is isolate the exponential part. I'm going to add the 1. X plus 1 equals 2 to the y. How do I get to an exponent? I got to log both sides. Specifically, which log? Log base 2. So I'm going to log base 2 of x plus 1. And I'm going to log base 2 to the y. So log base 2 of x plus 1 equals y. And then it's no longer y. It's f negative 1 of x equals log base 2 x plus 1. So it could ask you to find inverse of any kind of function, but it also could include exponential and log. Yeah.
Is this the last test of
No, you got one more.
the
But that last one is going to be 3 more sections, but it's going to pull back from cumulative. It's not just on those 3 sections. Yeah. It continues to, we do logs, we do solving log equations next. Like, it doesn't go away.
So
Yeah.
you're talking to me?
Well, he
Oh,
asked the
okay.
question, but you responded.
Oh,
So
okay.
I'm talking to you.
Okay.
Yeah.
From what Bailey said, like the log 3 of 2, how would you do that?
If this said log base 3 of 2 here, well, you'd have no variable. So it could be like 2x, if that's what you mean.
Yeah.
If it was 2x, then all the way down here would be 2y. Then at the end, I divide by 2. Yeah. Good on those? Okay, then came your log functions and all the graphs attached to it. So you could get asked in a multiple choice way or an open-ended way to find the domain, the vertical asymptote, describe the translations, what the end behavior individually, and then also you're going to get one big question that says graph the function. I expect you to have 3 points, so not an estimate, like you're actually graphing those 3 points. Find the vertical asymptote, the domain, the x-intercept, the end behavior using limit notation, okay? So if it looked like this, if it said f of x equals negative log base 2 of x plus 3 minus 1, remember there's 2 methods. One is make it its inverse, plug in for the x, and then switch your x and y's. The other is make this y equals negative log base 2 x plus 3 minus 1. We're going to solve for, we're going to get it into exponential, so we're going to add the 1. Y plus 1 equals negative log base 2 of x plus 3. I'd still have to get rid of the negative at the front. So I divide or multiply by negative 1. And I get negative y minus 1 equals log.
Here's what I found.
Oh, she's so helpful. Base 2 of x plus 3. And then I convert to exponential. So 2 picks up that whole thing. Equals x plus 3. And then the last step to solve for x would be to subtract the 3. So 2 to the negative y minus 1 minus 3 would equal x. And when I do it this way, I'm going to plug my points in to the y. So I'm going to set up a t-chart, but plug into the y. So I get 2 to the negative 1 minus 3. 2 to the negative 0 minus 1 minus 3. And 2 to the negative 1 minus 1 minus 3. So So minus a negative makes that positive 1 minus 1. That's 2 to the 0 minus 3. 1 minus 3. Negative 2. 2 to the negative 0 minus 1 is 2 to the negative 1 minus 3. 1/2 minus 3, which is negative 2 and 1/2. And then 2 to the negative 2 minus 3 is 1/4 minus 3, which is negative 2 and 3/4.
So do you always have to like put it into the exponential?
If you, well, either way, you're putting in an exponential form. Either you're going to find the inverse and it will be the exponential form. We'll plug into the x and then switch the x and the y. That's method 1. If you do it this way, you put into exponential without switching your x and y. You put it into exponential, but you plug in for the y.
Okay, but it always has to be exponential.
Always.
Okay.
Yep. It's way harder to say log equals something, right? Like you'd be guessing what log would be, and it's not always going to work out into an even number. Yeah.